State and prove multiplication theorem. So first we write this theorem is also called as multiplication in time domain property. First we write down the statement. So consider two signals x1t and x2 of t. If x1 of t, x1 of f and x2 of t, its Fourier transform is its Fourier transform x2 of f, then x1t into x2t, this is multiplication. Its Fourier transform is x1f and it is convolution x2 of f. This is multiplication and this is convolution. So now we write down the proof for this. According to definition of Fourier transform, according to the definition of Fourier transform, according to the definition of Fourier transform, we write Fourier transform of x of t is equal to x of f minus infinity equal to minus infinity to infinity x of t e raised to minus j2 pi ft dt. Therefore, Fourier transform of x1t into x2 of t is integration minus infinity to infinity x1 of t into x2 of t into e raised to minus j2 pi ft dt. This is equation number 1. Now using the definition of inverse Fourier for x of t, I will write here using definition of inverse Fourier transform for x2 of t. So this equation becomes x2 of t is equal to minus infinity to infinity x2 of f, here we give f dash e raised to plus j2 pi f dash of t dt. This is equation 2. Now here frequencies f and f dash are not same. Here frequency f and f dash are not same. These two different frequencies are different. These two frequencies are different. Therefore x2 of t is equal to minus infinity to infinity x2 of now we put equation 2 in equation 1. Put equation 2 in equation 1. Therefore Fourier transform of x1 of t into x2 of t equal to minus infinity to infinity x1 of t into minus infinity to infinity x2 of f dash e raised to plus j2 pi f dash of t dt dash into e raised to minus j2 pi f t dt. So we can write minus infinity to infinity x1 of t minus infinity to infinity x2 of f dash. Now it is e raised to minus j2 pi f minus f dash t df dash dt. Now we replaced f minus f dash by some value. It is equal to tau f minus f dash. Therefore f dash is equal to f minus and replace df dash by d tau. So this equation becomes now we rearrange these terms. Now we are rearranging the terms. So we can write it is minus infinity to infinity x2 of f minus tau d tau into minus infinity to infinity x1 of t e raised to minus j2 pi t dt. This is equation number 3. Now the second term in this equation represent, we write here second term in equation 3 represent Fourier transform of x1 of t, that is it is x1 of f. Therefore Fourier transform of x1 of t into x2 of t, it is minus infinity to infinity x2 of f minus tau x1 of f. So it is minus infinity to infinity x1 of f x2 of f minus tau d tau. So RHS term is convolution we write here RHS term is convolution x1 of f and x2 of f. Thus x1 of t into x2 of t, it is Fourier transform x1 of f into x2 of f. So the multiplication of the signals in time domain is equivalent to the convolution of their Fourier transform. Multiplication of the signal in time domain is equivalent to convolution of their Fourier transform. Now the next one is convolution theorem. State and prove. State and prove convolution theorem. So it is also called as a convolution in time domain property. This theorem is also called as convolution in time domain property. So first we write down the statement here. Consider two signals x1t and x2 of t. If x1 of t, its Fourier transform is x1 of f, and x2 of t, its Fourier transform is x2 of f, then x1 of t, x2 of t, this is convolution. Its Fourier transform is x1 of f into x2 of f. This sign is convolution, this sign is multiplication. Next is proof. So using the definition of convolution, we write here using definition of convolution, x1 of t into x2 of t, it is equal to integration minus infinity to infinity x1 of tau x2 of t minus tau t tau. This is equation number 1. Now we take the Fourier transform on both sides. So taking Fourier transform of both sides, we can write Fourier transform of x1 of t into x2 of t, it is Fourier transform of, it is minus infinity to infinity, x1 of tau, x2 of t minus tau d tau. This is equation number 2. Now according to the definition of Fourier transform, x of t is equal to x of f, which is equal to minus infinity to infinity x of t e raised to minus j by f t dt. Therefore, Fourier transform of minus infinity to infinity x1 of tau, x2 of t minus tau d, it is equal to integration of minus infinity to infinity x1 of tau, x2 of t minus j2 by f t dt. This is equation number 3. Now put equation 3 in equation number 2. Put equation 3 in equation 2. So Fourier transform of x1 of t convolution x2 of t minus infinity to infinity x1 of tau, x2 of t minus tau d tau e raised to minus j2 by f t dt. So we rearrange the term at RHS. We write here rearranging terms at RHS. We get Fourier transform of x1 of t convolution x2 of t, it is minus infinity to infinity x2 of t minus tau raised to minus j2 by f t dt into integration of minus infinity to infinity x1 of x1 of tau d tau. This is equation number 4. Now this above term, this is Fourier transform of x2 of t minus tau. So the first integration term represent Fourier transform of this first term. This first term indicates the Fourier transform of x2 of t minus tau. So using time shifting property, we write here using time shifting property, Fourier transform of x2 of t minus tau is equal to e raised to minus j2 by f t x2 of f. So equation 4 becomes, now we write here equation 4 becomes Fourier transform of x1 of t into x2 of t equal to e raised to minus j 2 pi f t into x2 of f integration minus infinity to infinity x1 of t d tau, which is equal to x2 of f minus infinity to infinity x1 of tau e raised to minus j 2 pi f t d tau. This is equation number 5. Now the integration term indicates Fourier transform of x1 of tau. We write here integration term indicates Fourier transform of x1 of tau. It is denoted by x1 of f. Therefore, Fourier transform of x1 of t into x2 of t, it is equal to x1 of f into x2 of f. So, the convolution of the signals in time domain is equivalent to the multiplication in frequency domain. Convolution of signal in time domain is equivalent to multiplication in frequency domain. Now the next is conjugate function property, duality or symmetry property. We will see it in the next lecture.